So we're going to discuss what a group is. Suppose that we start with a set G. So let G be a set. And suppose that we have a map. Let's call it star from G cross G to G. Now, what does this mean in simple terms? It means that to any two elements of G, we assign a third element. We denote the star of A comma B, so A comma B are elements of G, by A star B. Then G equipped with the operation star is a group if it satisfies three properties. First property, if we take three elements of G and we compose the first two. Actually, if we think about it, if we want to compose the three elements, then there are two ways we can do it. We can compose the two last ones and then compose them with first one, or compose the first two, so take A star B, and then compose it with C. We get the same thing for any ABC in G. So we call this associativity. There exists E in G such that A star with E is E star with A is equal to A for any A in G. Here one should note that such an element is unique. Why? Suppose that you had two of them. If E and E prime had this property, then on the one hand, you would have that E would be E star with E star, with E prime, because E prime acts this way. But then you can read it the other way around. And since E also acts this way, you will have that it's equal to E star, so to E prime. So the two elements would be the same. And of course, E is called the neutral element. So the second property is about the existence of a neutral element. And the third property is given A in G, there exists B in G such that A star B is equal to B star A is equal to E, where E is precisely the element whose existence is ascertained in the second property. Again, we might argue here that such a B is unique. Again, imagine that you had two of them. So you had A star B is equal to B star A is equal to E, and on the other hand, you had some other one, A B prime equals to B prime A P prime star A equals E, then what can you do here? Then you would simply have that B is equal to B operation with E, and that would be equal to B operation to A operation to B star. That's what E is. And this would be B operation with A operation with B star because of associativity. This is a routine argument, and this is E operation with B star, which is B star. So it's unique, and this is the existence of the inverse. So in other words, the properties that we have here are associativity, existence of neutral element, existence of inverses. There is one last property which is optional. So that's what a group is. But if in addition we have the property V, that A operation with P is B operation with A for any A comma B in G, which of course is the property that would be named commutativity. Then the group is called abelian. So in other words, to recap, if we have the first, the second, and the third property, then we simply have a group. If we have the first, the second, the third, and the fourth property, then we have a commutative, or we also call it an abelian group. Now, we should say a few things about the notation. So usually, non-abelian groups are denoted multiplicatively. So instead of a star, we put a times, which can also be omitted. So we write AB, and the neutral element can be denoted by 1. Sometimes you might see it as an E. And the inverse, which could be also called the reciprocal, is A to the negative 1. Abelian groups, commutative groups, are often denoted additively. So the addition, the star operation is denoted by an addition. So the operation is A plus B. The neutral element is denoted by 0. And the inverse is simply the opposite, which is denoted by negative A. Now, standard examples of groups can be found by taking, for example, Z, the set of integer numbers with addition, or the set of real numbers with also addition, or the set of non-zero real numbers with multiplication, or the set of rational numbers with addition, or the set of non-zero rational numbers with multiplication. All of these are groups. all of them are abelian groups. If we wish to give non-abelian groups, an example of non-abelian group, then we might as well use the most generic one. So if S is a set, then we denote by permutations of S to be all the functions from S to S that are one-to-one and onto. These are exactly the functions that permute the elements of S. The operation is composition. If S has at least 3 elements, then it is non-abelian. In particular, if S consists of the elements 1, 2, all the way to n, then this group is denoted by Sn, and it is called the symmetry group on n elements. So in some sense, the whole notion of a group abstracts the notion of operation. Of course, it's not just any operation. It has to be a pretty agreeable operation for which is associative, for which there is a neutral element, and for which every element has an inverse. And of course, groups end up being ubiquitous. We use them pretty much everywhere. And in some cases, they form the backbone of certain mathematical theories. And that's all we had to say about groups. Thanks for watching.